Astrophysics, exploring the cosmos and understanding the universe. The Astrophysics and Cosmology group focuses mainly on cosmology, the properties and evolution of the universe and growth of large-scale structure, galaxy evolution, how galaxies grow and change over time, and supernova, causes of type Ia supernova, modeling the spectrum of emitted light, uses standard candles to measure the expansion of the universe. We approach these problems using theoretical, computational, and observational techniques. We are involved with many current and upcoming astronomical survey projects that can address these questions. Supernovae are the largest explosions known in the universe, occurring when a star or stellar remnant is no longer able to support itself against the pull of gravity. As it collapses, the sudden release of gravitational potential energy drives an explosion. John Hillier has built the world's leading non-equilibrium radiative transfer code to model the radiation we observe escaping from supernova. He also uses this code to model the most massive known stars. Carlos Baidens studies supernova remnants to figure out what causes type Ia supernova. His work has given support to the hypothesis that merging binary white dwarfs is responsible for most of these explosions. Michael Wood-Vasey has used type Ia supernova as standard candles to measure the expansion history of the universe. His work has helped make the case that the universe's expansion is accelerating. Daniel Parafort is improving our ability to measure the expansion history of the universe by identifying peculiar type Ia supernova that have inaccurate distance measurements. The cause of this accelerating expansion is one of the central questions of cosmology, along with the nature of dark matter, the physics of the very early universe, and the growth of large-scale structures. Andrew Zender is a theorist who has worked on dark matter probes via gravitational lensing and evolution of stars. Arthur Kosowski has addressed many of these questions using the theory of cosmic microwave background radiation. Zender and Kosowski pursue constraints on particle physics using cosmological data, while Kosowski and Dan Boyanowski both study early universe inflation. The formation and evolution of galaxies, including their interactions with their environments, remains a major area of interest in astrophysics. Many cosmological probes rely on galaxies, especially their distances from us. Jeff Newman and Brett Andrews are observational astronomers who specialize in methods for measuring distances to galaxies from images and understanding how galaxy properties change with time. Rachel Bezenson is an observational astronomer whose research focuses on empirical studies of the formation, transformation, and evolution of massive galaxies through cosmic time. Dave Turnchek and Sandy Areu study quasar absorption line systems. Evan Schneider is a computational astrophysicist who studies how gas and stars and galaxies interact by running numerical simulations on supercomputers. A common theme connecting much of the work in the group is the use of astronomical survey techniques. The University of Pittsburgh was a member of the groundbreaking Sloan Digital Sky Survey. Michael Wood-Vasey served as scientific spokesperson for SDSSI. Brett Andrews, Jeff Newman, Michael Wood-Vasey, and Carlos Baidens are involved with SDSSIV, and Carlos Baidens continues as a member of SDSSV. Most of our faculty have used SDS data in their work. Jeff Newman and Carlos Baidens are both involved with the Dark Energy Spectroscopic Instrument, DESI, a project to build the next-generation wide-field multi-object spectrograph. Jeff Newman is a key member of the CANDELS survey, the largest ever sky survey using the Hubble Space Telescope. Arthur Kosowski participates in the Atacama Cosmology Telescope, ATT, collaboration, which makes ARC-minute resolution maps of the microwave sky. Rachel Bezenson has been involved with some large galaxy surveys spanning from the local universe to a few billion years after the Big Bang, including the NMBS, 3D-HST, and OBI surveys. She is a survey scientist for the LEGAC, Large Early Galaxy Astrophysics Census, ESO Public Spectroscopic Survey, and is actively involved in planning for the Galaxy Evolution component of the Prime Focus Spectrograph Survey. Finally, several of the faculty have leadership roles in the Rubin Observatory Legacy Survey of Space and Time, LSST project, Zentner, Woodvasey, Newman. Related to survey astronomy, Newman, Andrews, Woodvasey, and Badens are all interested in astronomical data mining techniques and related statistical questions. The Astrophysics and Cosmology group generally supports around 20 graduate students and 1 or 2 postdoctoral researchers. We also encourage undergraduate involvement in research. The STEPUP program, Survey of Transiting Exoplanets at the University of Pittsburgh, uses a telescope at Allegheny Observatory to discover planets orbiting candidate stars identified by the Kepler satellite and is run entirely by undergraduates. Group members participate in activities of PITPPACC and organize workshops on astrophysical topics. We hold regular Astro Coffee meetings to discuss new discoveries and research results. These meetings are open to anyone interested. Members of the group also organize educational activities at Allegheny Observatory, including public lectures and observatory tours. Our program consists of 2 components, coursework and independent research projects under the close supervision of a faculty member. The coursework is designed to give a solid background in the relevant areas of physics and math and to survey several of the currently most active areas of astrophysical research. We place a particularly strong emphasis on the independent research component, which allows students to carry out cutting-edge original research in astrophysics and to gain a working experience of what it is like to do professional astronomical research. A measure of our success is that a substantial fraction of our graduating seniors have co-authored 1 or more scientific papers published in the astronomical literature as a result of their junior paper or senior thesis work. Another measure of our program's overall effectiveness, and perhaps more importantly, of the quality of the students at Princeton, is the remarkable success our students have achieved in their graduate school applications and the jobs they follow. Our graduates go to graduate schools such as Berkeley, Caltech, Chicago, Cornell, Harvard, Santa Cruz, and other top schools. While many of our graduates continue in astrophysics graduate school and a career in academia, our program is very broad. A significant number of our students continue in other directions, including science policy, science education. One recent graduate is now the director of education at a major planetarium, space science, biology, and astrobiology, as well as in finance, law school, and medical school. Many of our students are winners of honorific fellowships. Our program is a rigorous one, intended to challenge and serve the first-class students that Princeton regularly attracts. In addition to the scientific excellence of the department, its relatively small size allows for an informal atmosphere and a highly accessible faculty, both of which are greatly enjoyed by our majors. Our program provides outstanding personal mentoring to the students and a family-like atmosphere, and is flexible and adaptive to the students' needs and future plans. Princeton is part of the Sloan Digital Sky Survey, SDSS, the largest 3D survey ever carried out of the universe. The SDSS is a multi-institution collaboration to map the universe in 3 dimensions by obtaining digital images of the entire northern high-latitude sky and redshifts of 1 million galaxies. What do you think of our video? Let me know in the comments section below. Before you go, please hit the like button and subscribe to my channel. Thanks for watching.